Welcome to the shop floor, everyone. I'm Party Batenda Olivier. As someone with a background in mechanical engineering, specializing in manufacturing technology and AI, I am absolutely thrilled to bring you today's explainer. We're demystifying something that literally sits at the heart of modern manufacturing: CNC machine parameters. If you're a secondary-level technical learner looking to make sense of all those numbers and dials, well, you are in exactly the right place. We're going to break down the complexities and give you the foundational knowledge you need to operate these machines safely and effectively. Okay, let's dive right into this. Here's our roadmap for the explainer. First up, the CNC Control Center. Second, what I like to call the Big 5 settings. Third, a step-by-step machine setup. And finally, workshop safety and success.
So let's kick things off with Section 1, the CNC Control Center.
Now, you might be wondering, what do we actually mean when we say parameters? In basic workshop terms, CNC parameters are simply the specific digital settings we use to control all of the machine's physical operations. They're the literal instructions that tell the machine exactly what to do. Think of parameters as the laws of physics for your specific machine. These numbers dictate the speed, the feed rate, how the tool moves through physical space, and even the strict boundaries or limits of the machine itself. Getting these settings right is the absolute secret to doing two major things: improving the final quality of your product and dramatically extending the lifespan of your machine. It ensures your work is incredibly accurate and, most importantly, completely safe.
Moving right along to Section 2, the Big 5 settings. Now, what's really interesting about this is how these settings interact. Let's break down the two most critical speeds you're going to deal with on a daily basis. On one side, we have spindle speed, which is measured in RPM, or revolutions per minute. This controls the rotation speed of the cutting tool itself, versus the feed rate, which controls the movement speed of the tool or the workpiece as it travels. Let's use a real-life car analogy here, because it really helps make this stick. Spindle speed is just like your car engine's RPM. You know, how fast the internal engine is actually spinning. The feed rate, on the other hand, is how fast your car is physically moving down the road. You need the perfect balance of engine power and forward motion to drive smoothly, right? Well, you need that exact same balance of spindle speed and feed rate to cut metal smoothly.
Okay, so once your speeds are dialed in, you have to dictate exactly where and how deeply the machine should cut. First up is the depth of cut. This literally determines how deep the cutting tool plunges into your raw material on any given pass. Next is the tool offset. Because every drill bit or end mill is slightly different in size, the tool offset adjusts the machine's position to account for that specific tool, guaranteeing pure pinpoint accuracy. And finally, we have the work coordinate system. Think of this kind of like the "You Are Here" star on a map at the shopping mall. It sets the absolute 0 point, or the starting reference, from which all other tool movements are measured.
Let's move to Section 3 and see how this all builds together. Step-by-step machine setup.
When you finally step up to the machine, the workflow is always sequential. First, you power on and immediately check your machine manual or the job specification sheet. Then, you load the correct physical tool for the job and enter your spindle speed and feed rate straight into the control panel. After dialing in your tool offsets and zeroing your coordinates, you reach the most absolutely crucial moment: the dry run. Before you ever allow metal to touch metal, you must run the digital simulation on the screen or physically run the machine just cutting air above the part. This verifies your parameters are exactly right and prevents catastrophic crashes. Seriously, never skip this step. Only when that is completely verified do you actually start the machining process.
This brings us to our final part, Section 4, Workshop Safety and Success.
Look, the reality of the workshop is that these machines are incredibly powerful. Safety must always be your baseline parameter. Before you even touch the machine, you got to wear your personal protective equipment, your safety glasses, and your proper boots. You absolutely must ensure your workpiece is firmly clamped into the vise or chuck. A loose part easily becomes a dangerous high-speed projectile. Always verify your parameter values one last time before hitting run. Keep your hands completely away from any moving parts while that spindle is turning. And remember this above all else: if you hear an abnormal noise, I'm talking a screech, a shudder, or some heavy vibration, hit that emergency stop immediately. Always follow your workshop's specific safety rules, no exceptions.
To summarize our core takeaway for today, proper parameter setting is the master key that unlocks everything else. It's exactly what guarantees dimensional accuracy, your own operator safety, a beautiful surface finish on the final part, and highly efficient production times. Whether your goal is to be a master machinist or a manufacturing engineer, knowing your machine manuals inside and out, understanding the specific machining requirements of your material, and actively engaging in regular checking and adjustment Well, that's the real formula that creates top-tier performance on the shop floor. So I'm going to leave you with this final thought. Are you ready to take control of the machine? Because by respecting the parameters, mastering the Big 5 settings, and strictly following your safety steps, you now have the foundational knowledge to approach any CNC machine with total confidence. Keep studying those manuals, always run your simulations, and stay safe out there. Thanks so much for joining us for this explainer, and we'll see you on the next one.